Hello, in this video we're going to review some solving equations. I just selected equations of different type, and so don't worry too much if you're not too familiar with one or the other type of equation. Solving equation is really similar no matter what type of function we're looking at. So let's look at several of those. The first one I have here is a quadratic, right? We have an x squared that makes this a quadratic equation. But still, our goal when we're solving an equation is to get the variable isolated so that we know what that value is. A variable is an unknown value, and that's what we're looking for, right? We want to figure out what is that x value. So we want to get x by itself, so we're going to do inverse operations, and we never start with the term where the variable is in first. We always go with, if we have a number by itself, that's the first thing that goes, right? So we have a subtraction of 12 here. Inverse operation tells us that we should add it then, so we're adding 12 to both sides, so that would go to 0, right? Negative 12 plus 12 goes to 0. And then we're left with 1/2 x squared equals, and then negative 4 plus 12 will be equal to 8. Alright, so the next thing we would have to do is now x squared is multiplied by 1/2. So to do the inverse operation, we would have to multiply by 2. And 2 times 1/2 goes to 1. So that would just be 1x squared, which is just x squared. And then 8 times 2 will be 16. And then finally, to get x completely by itself, we need to undo that square here. And to undo a square, the inverse operation will be a square root. So we're going to square root both sides, and therefore x is going to be equal to, and when we take a square root to solve that, that will be x plus or minus a 4. So don't forget your plus or minus, because if you don't, you'll only have a positive 4, and that would only give you one of the solutions, because there are actually two numbers that could be x here and would make that statement, this equation, a true statement. And if you're not sure, you plug in your values that you came up with and see if that actually would give you a true statement. So let's say if we plug in a 4 for x squared, if you put in a 4 here, you would have 4 squared is 16. 16 divided by 2 or multiplied by 1/2, same thing, right, would be 8. And 8 minus 12 will be negative 4, so that will be true. Now let's try negative 4. So you do negative 4 squared. Negative 4 times negative 4 is a positive 16, and then again we have 16 times 1/2 or divided by 2 will be 8, and 8 minus 12 will be negative 4. So both of those are working to make this a true statement. Alright, next equation. This is a linear equation, but we have variables on both sides of the equal sign. And you shouldn't let that bother us either. So here we're going to first, we need to get rid of those parentheses here. So we're going to distribute this 1/4. So we have 2x equals 1/4 times 3 will be 3 over 4x. And then 1/4 times 4 will just be 1, right? Because the 4 over 4 is just a 1. At this point, we have two x terms, so we need to combine them. So we're going to, this is a positive 3/4 x, so we're going to subtract 3/4 x. So when we subtract 3/4 x, I want to go here to the side and say, okay, so we'll have a 2, and we want to subtract from 2, we want to subtract 3/4. When you want to add or subtract a fraction, you need a common denominator. Well, this doesn't have a 4 at the bottom, it's a 1. So we're going to have to multiply top and bottom here by a 4. And so that will give us 8 minus 3. And then now both of those will be over 4, right? So common denominator now. And then 8 minus 3 will be equal to 5, and then over the 4. So this will become a 5 over 4. So 2x minus 3/4 x will be 5/4x. And that will be equal to 1. And then to get x by itself, we need to multiply by the reciprocal of this fraction, right? So we're going to multiply both sides by 4/5. And so the 4/4 goes to 1, 5/5 goes to 1. So that's just going to be an x. And then x is equal to 1 times 4/5, which is just 4/5. All right? And then again, you would check, right? So you will plug in a 4/5 here and a 4/5 here, and you will see if that will give you a true statement. The next equation, so let's erase that, put that paper back in the middle there. Here we go. The next equation is a linear equation, but again, we have parentheses on both sides, so we need to get rid of them. So we're going to distribute those coefficients. So 4 times m is 4m, 4 times 5 is 20, equals, and then we're going to distribute that 2 here. 2 times 9m is 18m, and 2 times -4 is -8. Now we have m terms on both sides, so what I'm going to do actually is I'm going to subtract 4m from both sides, and that would leave me with a 20 here, and then I want to add 8 to both sides, so that I only have m terms on the right and just a number on the left. So 20 plus 8 is 28. 18 minus 4 is 14, and that's an m. And then we divide by 14 on both sides. And so m will be equal to 28/14, which is just going to be 2. So m equals 2. And again, you would substitute in a 2 here and 2 here and see if you would get a statement that's true. So we can do that very quickly. 2 times 9 is 18. 18 minus 4 is 14. And 14 times 2 is 28. 2 plus 5, right? The 2 will be m. 2 plus 5 is 7, and 7 times 4 is 28. And 28 will be equal to 28, so that will be a true statement. All right? Number 4. This is an absolute value equation. And again, don't let that shy you away. An absolute value equation, we're just going to have to do one little extra trick. So first of all, we need to isolate the absolute value. So we have a plus 2 here, so we're going to subtract 2 from both sides, right? Inverse operation. And so I have the absolute value of x minus 3 all over 2 is equal to 6 minus 2, which is equal to 4. And at this point, when you have an absolute value, you need to recognize that an absolute value is a distance away from 0. So what this statement is saying is that whatever that is, it is 4 units away from 0. So what you want to think about is if 0 is right here, whatever that number will be, it will be 4 units away from 0. So 4 this way, and 4 that way, right? 4 units away from 0 could be on the right or on the left of 0. That means that this could be a positive 4 or a negative 4 when we drop the absolute value. With the absolute value, we're talking distance away from 0, and a distance is always positive. But once we drop the absolute value, then we're not talking distance anymore, we're talking positive 4 or negative 4, right? So that's one, when we drop the absolute value, we're going to say that's going to be equal to x minus 3 divided by 2 is equal to 4, or x minus 3 divided by 2 will be equal to negative 4. Either one of the two. And then you solve them separately. So here it's divided by 2, so we're going to multiply by 2, so x minus 3, and 4 times 2 is 8. And then we're going to add 3, so x is equal to 8 plus 3, which is 11. That's your first answer. And then here again, we are multiplying by 2 on both sides, right? So x minus 3 is equal to negative 8, and then we're going to add 3 to both sides, so x will be equal to negative 5, because negative 8 plus 3 will be negative 5. So we have two solutions, 11 and negative 5. And then when we're checking to see if they both give us a true statement, we get 11 minus 3, which will be 8. 8 divided by 2 is 4. Absolute value of 4 is 4, and 4 plus 2 is 6. So that will be a true statement. Let's try with negative 5. Negative 5 minus 3 is negative 8. Divided by 2 will be negative 4. Absolute value of negative 4 is positive 4, and 4 plus 2 is 6. So that would also be a true statement. So both those solutions are actually going to be valid. Alright, number 5. For number 5, we have two fractions here, and I put those there purposely to show you how to deal with fractions. You could do that different ways, really, but probably the quickest and easiest way for everybody is to cancel the fractions. And this is a 5, that's a 10, and that will give us a common denominator of 10. So we will multiply by 10 everything. We multiply everything by 10. So 4a times 10 will give us a 40a, and then negative 1 over 10 multiplied by 10, those 10s will become 10 over 10 is 1, so just minus 1, equals 3 times 10 will be 30a, and then 4/5 times 10, so 10 times 4 is 40, and 40 divided by 5 will be 8. And at that time, see, we don't have any fraction anymore, so that's nice and clean. We're just going to combine like terms. So we're going to move the a term on one side and the number to the other. So 40 minus 30 will be 10, so that's 10a is equal to 8 plus 1 is 9, and then we divide by 10 on both sides, and we get 9 over 10. Okay, and again, we could substitute 9 over 10 for a here, and then make sure that we get a true statement on either side. Alright, number 6 is an inequality, and I hesitated about putting that there because it says equation, but after all, an inequality, we're going to use the same steps to solve it than we would for an equation. So we're just going to have to get rid of those parentheses, just like we've done before. So we're going to distribute that 4. So we have 3x less than or equal to 4 times x is 4x, 4 times negative 1 is negative 4, and then the minus a back there. We're going to put our like terms together, so I'm going to go ahead and subtract 4x from both sides. Oops, I said 4x and I looked at the 3 and I wrote down a 3. Subtract 4x from both sides, so that will go to 0. 3 minus 4 will be negative 1x, and negative 4 minus 8 will be negative 12. Oops, little slip of the pen there. Okay, now we have a negative here, so we want to divide by negative 1, but that's when the equation and the inequality would have a different effect right there. When you divide or multiply by a negative and you have an inequality, you have to remember to flip that inequality around. So negative divided by negative becomes a positive. Because we divide by a negative, we're going to flip that inequality around, and it becomes now greater than or equal to, and then negative 12 divided by negative 1 is a positive 12. There we go. Alright, so we go to 7. 7 is a system of equation. So how do we solve a system of equation? Well, there are several ways we can do that. But when I look at my two equations here, I notice that this one has y and then x term, then a coefficient, constant back there. And this one has the y also. But now my x term is not here. It's over there. And then my constant is here when the one above has the constant over there. So we need to align our like terms. So we're going to reorganize that. So we're going to say, okay, 3y minus 2x equals 7. I'm going to leave the first one the way it was, and then I'm going to reorganize the bottom one so that my terms are aligned with this. The y terms were already aligned, so I'm going to leave this one. The 2 needs to be below the 7, so I'm going to add, because it's a minus here, I'm going to add 2 to both sides, make that a positive 2. And my 4x needs to move across the equal sign to be aligned with my negative 2x here. So since it's a positive 4x, I'm going to subtract 4x. And there we go. Now they're aligned. And when I'm looking at them, I notice that I don't have anything that cancels, right? When you do elimination, you want one of the variables that have to cancel. So what I could be doing is, let's change color here so we can really see it. What I could be doing is multiply that top one by a negative 2, and by multiplying those three by negative 2, I will end up here with a positive 4x, and a positive 4x minus 4x, that will go to 0. So that's my goal, right? I want one of the variables to cancel. So multiply all the way through by negative 2. So 3 times negative 2 is negative 6y. Negative 2x times negative 2 is a positive 4x, that was our goal, equals, and then 7 times negative 2 is negative 14. And then we're going to keep this one the way it used to be, 2y minus 4x equals and 2. And now, when I'm adding my like terms, negative 6 plus 2 will be negative 4y. 4x minus 4x goes to 0, and then negative 14 plus 2 will be negative 12. We only have one variable left, so now we can divide both sides by negative 4, and y will be equal to 3. Negative 12 divided by negative 4 will be positive 3. Once we have the y, we go back to one of our equations and substitute in a y. So it doesn't matter where we go. Let's just go maybe to this one. So we're going to say, okay, 2 times y, which is 3, minus 4x equals 2. That will be 6 minus 4x equals 2. We're going to subtract 6, so minus 4x. 2 minus 6 will be negative 4, and divide by negative 4x will be equal to 1. So the solution to this system, a solution to a system of equation is always a point, so we write it as a point, right? The x comes first, so 1, and then the y is 3. So that's your solution right there, 1, 3. Alright, so now we have another system, and we want to check, and we have the y's aligned, the x's are aligned, sorry, the equal sign, the x's, and the numbers. But none of them would cancel, right? However, I notice that if I multiply, let's make that, let's do that with an orange one so we can really see it. If I multiply the top equation by a negative 2, then I would have a negative 2y and a positive 2y, and those will go to 0, right? Now, it just happens that we have negative 2 here and a negative 2 here also. It doesn't always have to be negative 2. So just to show you, to prove my point, I'm going to pick a different way of doing that, just so that you don't think it's always a negative 2. So what I'm going to do instead is I'm going to multiply this bottom one by a negative 1/2. And so multiplying by a negative 1/2, 2 times negative 1/2 will be negative 1, because the 2's will cancel. So we have a negative 1y, so negative y. 6 times negative 1/2, so 6 over 2 will be 3, and we have a negative, so that'll be sorry, I forgot my equal there, so I have an equal. That will be negative 3x. And then 4 times a negative 1/2 will be 4 over 2 is 2, and that's a negative 2. Okay? And then this top one, then I'm not changing. I'm going to keep the way it was. So y equals, and then 3x and minus 5. So now when I'm going to add all of that, I notice that I have y minus y, so that goes to 0. I have 3x minus 3x, that goes to 0. Negative 5 minus 2 will be negative 7. That will simplify to 0 equals negative 7. Well, that's nonsense, right? 0 is not equal to negative 7. When that happens, when you get a statement that's not true and you checked your math and you're sure you didn't make a mistake, then you know that this is not true, so that will be a no solution case. That just means that those two lines, if we would grab them, would never touch each other. There will be no solution. All right, number 9. Number 9 is a quadratic, so I have to wonder, what can I be doing with that? And I'm thinking, well, it's equal to 0. Both of those terms, right, I have two terms, one here, one here. Terms are things that are separated by pluses or minuses. So I have two terms, plus in between them, right? And both of those terms have at least one x in it, so I could divide them both by x, couldn't I? So factor out an x. 6x squared divided by x would just be 6x, plus 4x divided by x would be just 4. But notice that I still have something in common, don't I? I could still divide both of those by a 2. So let's do that. So let's take that 2 to the front with the x. 6 over 2 will be 3, plus 4 over 2 will be 2. Okay, now that's as simple as it can go. I can't factor anything else out. So why is that helpful? I have a multiplication here. When you multiply two things, so you have two things that you multiply. You don't know what they are, but you multiply two things and you get a 0. Then you know that either this one is 0 or this one is 0. Has to be, right? It's called the zero product property. So either 2x equals 0, in which case if I divide by 2 on both sides, x is 0, because 0 divided by 2 is still 0. Or I have 3x plus 2 equals 0, so I'm running out of room. Let's see if I can do it here. 3x plus 2 equals 0, in which case I subtract 2. It will be 3x minus 2. Sorry, 3x equals negative 2 and divide by 3. So that will be x will be equal to negative 2 over 3. Negative 2 over 3 and x equals 0 are your two solutions. We had a quadratic. You have always as many solutions as your highest exponent, and so I have two solutions. Number 10 is also a quadratic, so I'm expecting two solutions here also, and so I'm looking for like terms first. I don't have another 2x squared, so that's going to stay there. Then I have a 2x here and an 8x on that side of equal. I'm going to combine them by subtracting 2x from both sides. Let me write that a little lower so I have more room. So 2x minus 2x goes to 0, and 8x minus 2x will be 6x. And then I have that 20 here, so I'm going to bring it across the equal sign. It's a positive 20, so I'm going to do minus 20 on both sides. And I don't have a constant term on that side, so it's just going to be minus 20 in the back there. Then I'm looking at what do they all have in common. Is there anything I could divide them all by? And sure enough, I could divide everything by 2. So I'm going to divide by 2, divide by 2, divide by 2. Don't forget that last one, divide by 2 also. Alright, so we're going to have x squared plus 3x minus 10, and 0 divided by 2 is 0. Now that's a quadratic, so we're going to factor that. So if you remember factoring, when you do not have a number other than 1 in front of x squared, that's when you're smiling. That's your easy factoring. And so you're just going to have to look at the negative 10. So what can you multiply to give you negative 10, but add up to give you that middle coefficient, which is 3. Multiply to give us a negative 10, add up to give us a 3. Sure looks like 5 times negative 2 will give me negative 10, and 5 plus negative 2 will give me a positive 3. So 5 and minus 2 are my numbers. So I have x plus 5 and x minus 2. And again, I'm multiplying and I get a 0, so just like up here, right? multiply two things and you get a 0, so either one of them could be 0, so we're going to say, okay, then either x plus 5 equals 0, in which case you subtract 5 and x is equal to negative 5, or x minus 2 equals 0, in which case we add 2 to both sides and x equals 2. So those are your two solutions. Again, it was a quadratic, so we expected two solutions, right? 11. So 11 is a rational function. So how do we deal with those? Well, the first thing you want to do is isolate your radical. So just like when we had the absolute value, the first thing we did was isolate the absolute value by subtracting 2 on both sides. We're going to isolate the radical by subtracting 2 on both sides here also. So minus 2, minus 2. And so now I have a square root of 3x minus 2 is equal to 6 minus 2, which is 4. And now I need to undo a square root. The inverse operation of squaring will be a square root, so I'm going to square both sides. Squaring a square root, they're just going to be inverse of each other, so they cancel. So on that side, on the left of equal, we just left with 3x minus 2. And then 4 squared is 16. And now we're going to do a two-step solving equation. So we add 2 to both sides. 3x is equal to 18. Divide by 3, and x will be equal to 6. And then we need to check to make sure we're good. Substitute in 6 for x. 3 times 6 is 18. 18 minus 2 is 16. Square root of 16 is 4. And 4 plus 2 is 6. And that is what we had. So that works. Alright, one last one. And it's a different looking equation, but it's still an equation. We have f of x is equal to 2/3 x plus 4. So that's a function, a linear function. And we're told that we need to find f of x equals 0, meaning if my function would be equal to 0, right, if my f of x is 0, so I'm going to replace my f of x here by a 0, what will my x be is what I want to know, right? If your f of x is 0, what will be that x, right? That's what we're solving for. F of x is 0, solve for x. So we're going to subtract 4 from both sides. So negative 4 is equal to 2/3 x. And now we're going to multiply by the reciprocal. So multiply by 3 over 2. Negative 4 over 3 will be negative 12. And then divide by 2. That will be your x. And therefore x is equal to negative 6. There we go. And that's it for solving equations.